Okay, polynomial expressions, okay? You're not solving for the letter, you're just simplifying. This gets us ready for the next unit, okay? 8x second minus 3x minus 10 plus negative 11x a second plus 2x minus 7. I said plus and minus a bunch of times so you don't make your three lines and try to do the exponent properties. You're doing a P1, P2 operation. So in the middle we have plus, so I should not see you doing rainbows and writing them over here, okay? We don't need this. So x second is the highest degree. So you make a slot for x to the second, not x to the fourth. You're not going to be adding the second powers together. That's a multiplication move. This is addition. And then we have x within the problem, and then we have constant. So x second, we got an 8 and a negative 11. You add the 8 to the negative 11 to make negative 3, but you don't add the 2 and the 2. That's a multiplication move, okay? X, negative 3 and positive 2. It's negative 1. Then negative 10, negative 7, negative 17, and there's your answer. Okay, next one, 6x to the third plus 12x to the second minus 1x, and then minus 15x to the second plus 7x minus 8. So again, I said plus and minus, so then we're under polynomial operations, P1, P2. Now, we have a minus. Well, we're going to do it the same way we're doing this one, except we got to reverse P2. So plus P2 is negative 15, negative 7, positive 8. Okay, so when I'm looking through here, I have x third, x second, x second, x constant. So x third's the highest, okay? Then we do have some x second, we do have some x, and we do have at least one constant. Okay, so x third, we have 6, and we don't have x to the third power in P2, so it's just 6. X second, you got a 12. And then a negative 15. 12 plus negative 15 is negative 3. X, you got negative 1x and negative 7x. Combine those, it's negative 8. And then constant, you don't have any constants here. You just have the positive 8 in the second one. Remember to put plus between them. Okay, next one. Again, 5x to the fourth. I'm going to put that in parentheses. And then in the other parentheses, so if you're like, oh, there's no plus minus here, but there is in here, 2x to the third minus 3x to the second plus 5x minus 1. So we're going to do P1, P2. Actually, I'm going to leave it at P1. Technically, that's not a polynomial. It's called a monomial because there's no plus or minus, so it's just one single term, but we're going to stick with P1, P2. Okay, so all you do is, now you're multiplying, because there'll be a times dot. Now you start distributing. 5 to 2, 5 to negative 3, 5 to 5, 5 to negative 1. So there were 4 rainbows, so I'm going to write the 5x to the fourth out 4 times. Then I'm just going to now multiply by each term. So 2x to the third, negative 3x to the second, 5x, and negative 1. Okay, so 5 times 2 is 10. Now what the x is, now you add the powers because now you're multiplying. Okay, 4 plus 3 is 7. 5, and put the x to the 7th. Don't just put a random 7. 5 times negative 3 is negative 15. Then x, 4 plus 2 is 6. 5 times 5 is 25. Now you got to take the x to the fourth times the x. So if the sx is to the fourth, we should probably put a 1 there so we know we're adding 4 plus 1, and that's 5. Okay. 5 times negative 1 is negative 5. We just have this single x factor. It's to the fourth power, so that's what I put. Now you're done multiplying. So when I'm lining up my slots, I'm putting pluses just like I did here. Now I'm doing what I'm doing here, just written differently. Okay, x to the 7th is your degree, okay? And we have x to the 6th. Is x to the 5th in the house? Yep. Did we end up with any x to the fourth? Yes, we did. We did not end up with x to the third. We did not end up with any x to the second. We did not end up with any x. We did not end up with any constants. So I've just put a 10, a negative 15, a 25, and a negative 5. Okay. Okay, next page. 3x minus 7 is P1, P2 is 1x plus 5. So again, another multiplication problem. This time I have two things in P1 that need distributing. So 3x to 1x, 3x to 5. Then negative 7 also needs to be distributed to the same two terms, 1x and 5. So this is called the FOIL method because there's 4 products. That's the most common type of P1, P2 multiplication. I didn't say it's the only type, I said the most common. So 3 times 1 is 3, x times x is x to the second, 3 times 5 is 15 with x, negative 7 times 1 is negative 7 with x, and then negative 35. Now, you're done multiplying, now you're adding what's possible. Notice I said adding, so when I line up my slots, I put plus signs. So x second is your highest degree. Then we have some x, and we have constant. So x second, you have the 3, that's it. X, you got the 15 and the negative 7. You want to add those. That adds to 8. And then negative 35. Okay, next problem. We have 3x minus 2. That's P1 times 2x to the second minus 5x plus 6. That's P2. Same thing we're doing here. It's just 2 more products to find. 3 to 2, 3 to negative 5, 3 to 6. And then times 2x to the second, and then negative 5x, and then 6. Now that's been distributed. Now we do follow suit with the negative 2. This will be multiplied by the same 3 things. Three times 2 is 6. X times x second, that's a 1, so it's going to be 1 plus 2, and that's 3. 6x to the third. 3 times negative 5 is negative 15. X times x, x to the second. 3 times 6 is 18, that would be x. Negative 2 times 2 is negative 4. This is my only x. Again, if you only have a single x factor, you just put it down with the power. If there's a power there, put it. If there's not, you don't put it. Negative 2 times negative 5 is 10. We just have this x factor here. If it doesn't have a power, we don't need one. And negative 2 times 6 is a constant, negative 12. Okay, so x third, x second, x second, x constant. Okay. So x third is the highest. We did have some x to the second. We did have at least one x term. There's actually 2, but I said at least 1. Then we do have at least one constant. So x to the third, you got 6. X second, I see we have this and this. So negative 15 and negative 4. Those are added. And it's negative 19. Notice I said added, that's why you're putting plus signs, okay? Then x, we have 18 and 10, so it's 28. Because what are we doing with these? We're adding them, which is why we need to put plus signs. So the multiplication game's over after I get these. And then negative 12. Okay, so 6x to the third plus negative 19x plus 28x plus negative 12. Next problem, we have a parentheses. Inside the parentheses, we have 4x minus 5, and outside parentheses, we have a 2 power. Now, you're still not doing the 3-line exponent properties because you have a minus symbol. Okay, minuses and pluses disqualify that. So P1 means it's a polynomial. And then I get rid of the 2, and P2 is just exactly like P1. Okay. Okay, multiplying time. 4 to 4, 4 to negative 5. Then negative 5 to 4, negative 5 to negative 5. So 4 times 4 is 16. X times x is x to the second. 4 times negative 5 is negative 20. We just have this single x factor. It does not need to have an exponent if it doesn't. Negative 5 times 4 is negative 20. Then x. Negative 5 times negative 5 is 25. By the way, it does need an exponent if that has an exponent. But if I don't see the exponent on the x factor, don't need it. Now if it's x second, I need to put the second. Okay. Then x second. Here's your degree. You got some x and you have some constant. So x second, we have 16. X, we add negative 20 and negative 20. It's negative 40. And the constant, you have 25. Okay, next problem. P1, 4x minus 2 times P2, 4x plus 2. It's another times, okay? I'm not sure why I put another one, but I did, okay? So 4 to 4, 4 to 2. It's 4x, though, not just 4. Okay. Then negative 2 to 4, negative 2 to 2. So 16, and then the x times x makes us an x to the second. That's a 2 I just put. 4 times 2 is 8. This is my only x factor. If it doesn't have an exponent, I don't need to put one. Negative 2 times 4 is negative 8. X. And then negative 4. So x second, x constant. So we have x second, we have x, and we have constant. So x second, we have 16. X, we need to add 8 to negative 8. That makes 0, so that term just goes away. Okay? And that includes the letter too. And then negative 4. So 16x to the second power plus negative 4. One thing, if you see these answers in a textbook, you won't see plus negative. It will be written as minus. Okay, a garden has dimensions of 15 by 17 feet. You're going to build a rectangular border that's the same width on every side. So let's draw this picture here. Didn't give you, don't do it here. You need this for workspace. And 15 by 17. It doesn't have to look right. It just got to get the job done. Okay. So now I'm building a border on the outside around every side, the same width all the way around. Okay, so measure your length, that's 15, and then this would be x and x. You're allowed to use x because it says it's the same on every side. Okay. So this is 17, then x and x. Okay. All right, write a polynomial expression that represents the combined area of the garden and border. So area is a multiplication of polynomials with the length and the width. Now I need to fill this in. Now the length is the bottom part. You can apply 1 in front of your x's. You take 1x plus 1x. That would be 2x. It's not 2x to the second or x to the second. That's a multiplication thing. I'm about to do multiplication, but here when I'm simplifying this, I'm adding the terms. Okay. Then here's the same thing. It's going to be a plus 15, obviously. Then 2x plus 17. Okay, FOIL time. Means distribute time. 2 to 2, 2 to 17. Then 15 to 2x, 15 to 17. So 2 times 2 is 4. X times x takes our x to the second. 2 times 17 is 34x. 30, and then just set x there. And then 15 times 17, I need to use a calculator, 255. Okay, so the x second, x constant. So we use the x to the second slot. We're going to need a slot for x, and we're going to need a constant slot. So x to the second is 4. X, 34 and 30, that adds to 64. And then my constant is 255. That's the end. Now the next part's easy if you know how to use a calculator. Use your expression to calculate the combined area, sorry I misspelled area, of the garden and border if the border has a width of 8 feet. What that means is these x's are now going to turn into 8's. But all I need to do is replace the x variables with the value of 8. So a equals 4. And now you empty your parentheses. Remember, the second power has to be applied outside the first one, the first parentheses. So I replace these with 8. So we will be taking 4 parentheses 8. Remember to get the plus signs in place, otherwise you're going to get a weird answer. Okay. I got 1023. So the area is 1023. You can either write SQ feet or feet to the second. Square means to the second. Okay, it's the same.